So in this video I will explain about the dehydration of alcohol to alkene, which I will convert the 3-dimethyl to butanol to 2,3-dimethyl to butene. So the first step is the protonation of OH group at alcohol. So this step involves the hydroxyl group's protonation in 3-dimethyl to butanol. So the H2SO4 facilitates in this step, which the H2SO4 will donate a proton to the hydroxyl group's oxygen atoms in 3-dimethyl to butanol. Within the H2SO4 molecule, the oxygen atoms are more electronegative than the hydrogen atoms, leading to partial negative charge on the oxygen atoms and partial positive charge on the hydrogen atoms. This electronegativity difference makes the H atoms electrophilic sites, exhibiting a partial positive charge and attracting electrons from a nucleophile. So, as an electron-rich atom, the oxygen atom on the 3-dimethyl to butanol will readily accept the H atoms on the OH of the H2SO4 by using one of its lone pair. The oxygen atom on 3-dimethyl to butanol will attack the H atoms on the H2SO4. So the sigma bond between HO, which is this one, of the attacked H and O atoms of H2SO4 will be broken, and both electrons of the sigma bond will push toward the more electronegative oxygen atom, which is this one. So in this protonation step is crucial because it transforms the OH group into a beta leaving group, facilitating the subsequent elimination reaction. So the beta leaving group is H2O, which will be eliminated in the next step of the mechanism. So this one is formed because of the deprotonation of H2SO4. So we go to the next step, which is this. So the H2O, this one, is eliminated by breaking the weakened sigma bond of C and O. So the two electrons from the sigma bond are pushed toward to the oxygen atom, as it is more electronegative than the carbon atom. So here it will eliminating the water, results in forming the secondary carbocation. So we go to the third step, which is the rearrangement. In this carbocation intermediate, a neighboring of H atom, along with its bonding electrons, migrates to the carbon atom, carrying the positive charge. This results in forming a new carbocation at a more stable position. So the hydride ion shift, which is this, from the C adjacent to the positively charged carbon to the carbon bearing the positive charge. So the hydride ion and the positive charge migration occurs simultaneously. So after the 1,2 hydride shift, a more stable carbocation is formed. In this case, the positive charge is located on a tertiary carbon, which is more stable than the previous secondary carbocation. So the rearrangement allows for a more substituted and therefore more stable carbocation, leading to a more efficient and selective reaction. Now we go to the fourth step. So this one It will act as a nucleophile base and attacks the H atoms of the C atom adjacent to the C bearing the positive charge. According to the Safe rule, the more alkyl substituted alkene is the major product in an elimination reaction. The reasoning behind this rule is that the more alkyl substituted alkene is thermodynamically more stable and therefore favor this additional electron density stabilize the alkene. Thus, the this one it will attack the H atom on the on the C adjacent to the C plus, forming 2,3-dimethyl 2-butene, which is more stable instead of I'm sorry. So the two electrons of the sigma bond between the CH are pushed between the CC to form a pi bond. So this process will break the sigma bond. So the formation of 2,3-dimethyl 2-butene is the major product according to the Safe rule. So it is more stable compared to compared to compared to 2,3-dimethyl 1-butene. Okay. So because of its carbon-carbon double bond has more alkyl substituents, which is more substituted alkenes benefit from the inductive effect, where the electron donating alkyl groups can donate electron density to the carbon-carbon double bond. So in this process, the process of this will obstructing a proton on the previous step. So this will result in the reformation of the H2SO4 structure at the end of the mechanism. So that's all for my explanation, and I'm sorry if there's a mistake. I hope that you can understand what I'm saying. So thank you.